When it comes to making cases for old, obsolete cartridges using commonly available alternatives, one issue usually ran into is the rim thickness. Old black powder cases are typically number 1, rimmed cases, and number 2, those rims are thicker than most common cases today. And when I say common cases, I mean the 4570 family, including 4570, 4590, and longer, and the 5070 family, such as 5070 and 5110, which aren't exactly the same case with different lengths, but for the purposes of this discussion, I'm lumping all these together. If I want to, say, use a 4570 as a base to make 11mm Mauser, I need a way of adding to the rim thickness in order for the cartridge to headspace properly, since most rimmed cases headspace off the thickness of the rim. Previously, I had slipped an O-ring down the body of the case. It works, but isn't ideal, since it doesn't provide a positive surface for the extractor to pull the case out of the chamber. A metal O-ring just isn't practical either. The rim only needs to be around 20 to 30 thousandths thicker. That's approximately the width the O-ring would need to be as well. A metal O-ring, or a washer, that size just wouldn't be very durable. The way to improve its durability would be to attach it permanently to the case. I don't think I'd fully trust epoxy, and soldering on it isn't an option, since you really don't want to heat a case head to the level needed for soldering. It could weaken it and cause a failure. If only there was some way to fold the existing rim upwards to increase its thickness. That's exactly what I did here to make a 5070 out of a 32 gauge brass shot shell. I supported the case on a rod, then lightly hammered the rim to fold it over. This works because it matches the geometry of a lot of old cartridges. The rim thickness is measured as the distance from the front of the rim to the back of the cartridge. This face here, the bottom corner, really doesn't matter. In fact, a lot of old cartridges have this area stepped. One example is the 11mm Mauser, intended for use in the Mauser 7184 repeating rifle. The base of the cartridge is called the A base, and the ejector has a step in it to push the case out using this area. The downside to manually hammering the rim is how long it takes. To make this, I lightly tapped all the way around the rim in multiple passes at multiple different angles. I probably have around 10 minutes invested into each case. I want a faster way to fold over and thicken the rims. For this experiment, I'm going to use 4570 brass because I have a lot of it. Let's move over to the lathe. I could hold the case in the 3-draw chuck, but with only 3 points of contact, I need to make it very tight in order to hold the case well. But the tighter I make it increases the risk of crushing the thin walls of the case. Instead, I'll open up the case jaws in order to hold it in the 6-sided collet block. The collets will grip all around the case, providing a much better hold by default. And also the case will retain its shape as the collet is tightened. The collets I'm using are ER32 collets. They're double tapered. The slits all over allow them to clamp down at the front and at the rear, which provides a good grip on straight-walled cases like 4570. To fold over the rim, I have this single knurling tool, but instead of the toothed wheel, I replaced it with a ball bearing. I'll add it to the tool post and set the angle. Something like this should work. Then I'll align the center of the wheel against the corner of the rim. It should be as simple as driving it in. Actually, the angle seems too shallow. I'll add some more. Something like this. That's working. Then I can reset to the same angle as before in order to smooth the base of the cartridge. Looks like that worked. I'll remove the case from the collet. The case doesn't look to be deformed at all. The collet held it well. But before we take a closer look at the results, I'll try it again on another case. I'll reset the angle of the tool post to where it was before, then drive it in again. This top-down angle should provide a good look as to what's happening. You can clearly see the bearing folding the rim forwards. I'm not sure if this second angle is necessary, but we'll see in a bit how it looks. I'll get the case removed from the collet in order to take a closer look at the results of the process. And here they are. For comparison, I added an unmodified 4570 case in the middle. Clearly the rims on the two cases on either side are thicker, but just how much thicker are they? First, I'll measure the 4570 as a basis for comparison. That's 68 thousandths. But I can't simply measure the modified cases in the same way, because again the rim thickness is the distance from the front of the rim to the rear of the case. Instead, I'll lay this block across the rear and then measure using that. First, I'll measure its thickness. Call that 310 thousandths. Then, laying it across the rear of the case, I'll get both it and the rim and the calipers. I'll subtract 310 from this measurement. That results in the rim thickness, 78 thousandths. Measuring the other case now. It's 85 thousandths. Two comparisons can be made here. First, how much thicker the rims are than the unmodified 4570. 9 thousandths thicker on the left and 17 thousandths on the right. If those don't seem like much, percentage-wise, they're 13 and 25% increases. Clearly this process is working, but I think I can get the rims even thicker. The second comparison that can be made is between the two cases. There's an 0.008 difference. I folded over the rims by eyesight and feel. Consistency and repeatability can be improved, and that starts with the brass used. Through this process, I learned that some cases have different rim dimensions. I had bought a large bag of 4570 brass at a gun show, and in it is mostly two head stamps, RP and WW. But looking through that, there's two types of rim shapes as well. You can see the difference here. The ones on the right, with the more squared base of the rims, are perhaps better suited to this process. There's more material in which to fold over. What's strange though, is that it's not the head stamps that seem to dictate the rim shape. Both of these are marked RP. From this angle, you can clearly see the bevel on the case on the left that's not present on the right. I found two WW head stamps that have different shapes as well. Again, more squared on the right, though perhaps not as much as the RP. For the sake of repeatability, I need to sort by rim shape, and only use those with the squared off rims. Another problem with this process is how I'm holding onto the cases. Using a collet instead of the 3-jaw chuck is the right idea, but the issue is how the collet is mounted to the lathe. Holding the collet block in the chuck just isn't the right way to do it. It puts the rim of the case 6 to 7 inches away from the spindle, putting undue wear onto the lathe. The runout, or how off-center the case is spinning, was more than an acceptable level, especially once force was applied. These collet blocks just aren't meant to be used like this. They're meant to be held stationary in a vise in a mill. What I need is a better way to hold the collet in the lathe. I have an idea to do so, and I think that it can also be used to provide more consistent results, as well as allow me to push it harder. That's where this comes in. It's a collet chuck that mounts directly onto the spindle. This will also bring the work much closer to the headstock of the lathe, and it should also be more precise, with less runout. Actually, this doesn't directly mount up. I first need to machine a backplate. This hunk of cast iron is already the right diameter overall, and the bolt holes are even in the right place. However, it does need this small step turned down slightly in order to fit the back of the collet chuck. And it needs to be a very good fit, because this is where the precision will come from. I'll set up the lathe to do just that. The problem is that I usually don't work this close to the headstock. I'll need to remove my chip shield to move the cross slide near enough. And even the backsplash needs to be pushed out of the way. Then I can slowly work this down to the correct diameter. On that last pass, I took off only one thou, which looks to have done the job. That's a good solid fit on there. Now to true up the front face. Next I can get the lathe reassembled. I don't need to move the cross side over as much anymore. Then I'll install the collet chuck. And now that the collet chuck is mounted, I'll get this piece of precision steel rod chucked in order to measure the run out. I'll mount an indicator, get it centered on the rod, and then zero it out. As close as I can get it anyway. Each of the lines on this indicator are 1/4 of a thousandth of an inch. I can barely see any movement at all. Maybe a 10,000th or two. High or low spots aren't very discernible at this scale. I don't necessarily need this level of precision to turn brass cases, but it will come in handy for other things. And with that, I'll take the collet chuck for a test drive right now. Before I start using this too much, I need a better tool to hold it still as the collets are tightened. I'm going to make a simple tool called a Tommy bar to replace the Allen key that I've been using to tighten and loosen the collets. And that's a much better fit than the Allen key. It won't deform the metal as the collets are loosened or tightened. I didn't bother with any polish or finish. I just need something that works. I could start turning the cases now, but in order for it to be repeatable, I need a way to locate the cases in the collet. It would be ideal to have some sort of internal stop that would not only allow the cases to be located, but also provide support, preventing the cases from sliding inwards from the forces involved. I need something inserted into the taper and the headstock. The only thing I have that fits in here is the center, but it would sit around here, and there wouldn't be enough room for the cases to fit where they need to, within the collet to be properly supported. If anyone has any ideas, let me know. For now, my best thought is to use an indicator on the carriage. This will allow me to measure how far it needs to move in order to fold the rim over to the correct thickness. It will take some trial and error, but once figured out, it should be fairly repeatable. With the case tightened in the collet chuck, I'll touch off the bearing on the corner of the rim. Then zero the indicator. I won't be watching this just yet. Instead, I'll watch the case. I'll keep going until it looks right. Then use one of the earlier cases to compare. It needs a bit more here. This looks pretty good, but with the forces required, the indicator should be red as it's running. Starting from 0, that's measuring 20 thousandths without any force applied, up to around 29 to 30 thousandths with force. I think that's it. I'm going to stop here, and I'm not going to bother going at it with a different angle. I don't think that's all that necessary. To repeat this on another case, I'll move the indicator and the carriage out of the way in order for the case to be removed. Once the new case is added and tightened, I'll touch the wheel onto the rim again. Then add the indicator back. And zero the dial. I'll feed it in until it gets to the 70 again, then hold it for a few seconds. That whole process took maybe 2 minutes per case. Once in a rhythm, I could probably get that down to 1 minute to a minute and a half. I'll see how these two compare. I'm not expecting a perfect match. Something within a few thousandths would be acceptable. Using the same block as before, that measures 310 thousandths. The rim thickness here is measuring 82. The other piece, its rim measures 85 thousandths. I think a 3 thousandths difference between the two is just fine. Folding the rim over also increases diameter. I'll measure just how much. This first one measures 610 thousandths. And this one is 612. In comparison, an unmodified 4570 measures just under 6/10 of an inch. I could just trim off the extra 12 thousandths, but to make 11mm Mauser, I need to go down to 0.585. Due to the shape of the rim, a bit of the thickness was lost by turning it down. Measuring it, it's 80 thousandths, a loss of just 2 thou. It's smaller due to the upturned shape of the rim. The loss in the diameter results in a slight loss in the thickness. But how does it compare to the 11mm Mauser I'm trying to duplicate here? Its rim thickness is 90 thousandths. That leaves 10 thousandths more to go. Or, that could be close enough to work as is. One added benefit to this process is that the rim is now much closer to the A base of the 11mm Mauser. I could easily make a form tool for the lathe to cut it accurately and quickly. But I'll save that for a later video. This video is about theory, and whether it's possible to not only increase the thickness of a case's rim, but to do so quickly and accurately. I think I've proven that. Let me know your thoughts down in the comments. Is this a good idea? Can it be taken a step further? Or am I wasting my time? Am I still putting undue wear onto my lathe? Did I trick you into watching a machining video? Thanks for watching.